Hello to my wonderful support class. We live in crazy times, don't we? Anyway, somebody asked if I could explain a couple of expected value problems, and those are the type that are not the best to figure out for through text. So I just decided to make a couple of videos. So hopefully these help out. Okay, so here's the problem we have. At this year's state fair, there was a dice rolling game. If you rolled 2 dice and got a sum of 2 or 12, you won $7. If you rolled a 7, you won $2. Any other roll was a loss. It cost $1 to play the game with 1 roll of the dice. What is the expectation of the game? Round your answer to the nearest cent. Okay, so for these, the expectation really tells us that they want expected value. And whenever I do expected value, I really like doing a 3-column chart. So result, outcome, and probability. Yeah, whatever. Probability. So result. So what's one thing that could happen? So maybe in this you say, oh, I roll a 2 or a 12. Or maybe your answer to this is $7. Either, whatever, just so you know the one possibility. And so the outcome for that, because it is $7 and you cost $1 to play, that means that your outcome is you're going to be $6 richer. We'll deal with the probability column in a second. So another result is that you rolled a 7, or you could say won $2. And so again, if you win $2, but you have to pay $1 to play the game, then your outcome, your change, would be a +1. Positive. Okay, so what's the other possibility? What's the other possible result? Your other possible result is that you lose. And if you lose, then your outcome, you lose the money that you put in. Okay, so we've got our result and outcome. So now let's talk about probability. So the probability of rolling a 2 or a 12, we've got pretty much 2 options, right? You can roll a 1 and a 1, or you can roll a 6 and a 6. And so if you remember from, what was that, 3-2? Lesson 3-2, when you did that chart, there are 36 different combinations that you can roll your die. And so if 2 of these come up, then my probability is going to be 2 out of 36. Okay, rolling a 7. So rolling a 7 means I've got, let's see, well, I can do a 1 and a 6. I can do a 2 and a 5. I can do a 3 and a 4. I can do a 4 and a 3. I can do a 5 and a 2, and I can do a 6 and a 1. So counting those up, 1, 2, 3, 4, 5, 6. There are 6 possibilities out of our total of 36 different ways of doing it. Okay, so probability of losing. So there's a couple of different ways you can figure out to do this. You can go to that chart and count up all the different, all the different combinations that are not 2, 12, or 7. Or this losing would be a complement. And so to figure up the complement, we can add these 2 together and then subtract it from 1. Or we can add the 2 and the 6 together and subtract it from our total amount of 36. I think that's what I'm going to do. So the 2 plus 6 is 8. And then because I know there's 36 total, and if I subtract out the 8 that are not losing, that gives me 28. So that means that my probability is I have 28 different rolls that out of the 36. Okay, so I'm going to erase this side. No. So now let's talk about how to find expected value. Expected value is outcome times, that's my big times, probability. So let's do that. So outcome times probability, outcome times probability, outcome times probability. And you can just throw this into your calculator and get the decimals. I'm going to do it as fractions because we have these common denominators. It'll be just as easy. So remember, multiplying fractions, top times top times top, bottom times bottom. So if I multiply that, I get 12 over 36. I get 6 over 36. And I get negative, this one's negative, negative 28 over 36. Now remember, when adding and subtracting like denominators, then you just add and subtract the numerators. So these two come up to 18, and then my negative 28, if I add all these together, I get a negative 10 out of 36. So now I'm going to have to go to my calculator. Once I plug that into my calculator, remember this is just a division, I get a negative 0.272727, and so on and so forth. And so the problem asked for it, round your answer to the nearest cent. So that means 2 decimal places. So that means that the answer I am going to go ahead and plug in is going to be a negative 0.27 cents. That means that on average, whenever I play this game, if I average all those plays together, then each time I'm going to lose 27 cents. Or you could say of it that the state fair people, the people running the game, they will have to pay out some. They will, but a lot of times the people will lose. And so they can kind of think of it as each time somebody plays, on average, they're going to make 27 cents. So hopefully this was useful. I'll do another one for the next one, and talk to you soon.